Hi, my name is Jeff Burke. I'm from UCLA. I'm just going to give a quick introduction to two different demos to close the day. And one that is pretty simple and small in its scale, and then one that's been part of an ongoing project for some time. The first one is actually going to connect to what Baishuan introduced in the morning, so talking about IoT over NDN. Before I do that, Leisha said we were supposed to explain, to people whether NDN can be used in the real world. So I wanted to mention a company that we're collaborating with called Operant Solar that just entered their second year of second cycle of Department of Energy funding. And they are using NDN, so you can see on the Department of Energy website the summary of their project. They're a startup that's using NDN for essentially long-range wireless over the LoRa, these long-range, low-power radios. And they are interested in NDN in order to be able to do geo-forwarding, so to easily direct data to devices based on where they're located, and to be able to get away from having to deal with name-to-address mapping, among other things, and to use multiple radio technologies, and hopefully, eventually, the same fundamental networking architecture over all those things. And so their sort of, the secret sauce is proprietary, but the libraries are the NDN Squirrel libraries that Jeff has written and are available open source. So one of the reasons that we're building libraries in Squirrel is actually to help with this project get NDN out in the wild. So we'd be happy to talk about it, but it's an example of essentially an IoT project using NDN that is going to go into field trials this year on a small scale, and then if all goes well, go beyond that. And so what we want to talk about today is not specifically what happens in that application, but just generally the idea that NDN primitives are well suited for IoT applications. And so what Yanbiao is going to talk about are building up a bootstrapping, discovery, and data consumption in a home IoT setting with very basic primitives from the NDN architecture. We have a couple of papers in IoTDI 2016 and 2017 that talk about how to go from those concepts, what we're going to show today, to a more sort of extensive framework for IoT. But we thought we would focus on kind of illustrating the basic use of the basic primitives. But here's, for example, the paper that we're talking about. So the kind of intuition in NDN for IoT is that we do lots of things in commercial IoT deployments, whether it's Nest or Ring or home security systems that rely on the cloud to find other devices that are part of our system that we want to talk to. Oftentimes because we're on a different network, but sometimes because it's just simply that the cloud provides a persistent name by which to rendezvous with other devices. And we also use it for managing trust. And so a lot of typical cloud-centric IoT architectures look like this. And there are some things that even though the cloud is helpful, it really don't make sense for using something far away to rendezvous with devices close to us, right? And so based on all the things that Baishuan talked about earlier, it seems like we should be able to do better with NDN. And so what Yanbiao is going to talk about is just a simple scenario with a couple of IoT devices, one of which has been elected to be a authentication server. Doesn't have to be just one server, but think of that as maybe an access point in the home. Could be a home server, home router, anything like that. And a number of devices that are going to use that as a root of trust to bootstrap local communication without relying on the cloud. And so he's going to walk through that process on just on a series of virtual machines so that we can do it quickly. But these could be Raspberry Pis, so that's what they have in the back, but for prototyping. Or we have some libraries that Alex pointed out earlier for doing similar things on constrained devices like an Arduino. So here we're going to do it on a VM, Linux VM, but you get the idea that this could be happening on smaller, more constrained devices.
Later, I will show you a very simple example about how NDN enables the cloud-independent home IoT network. So, before going to the demo, I will first highlight some basic assumptions. For our scenario, there are 3 preconditions that should be matched. First, each device can reach each other via some physically connectivity. Secondly, each device must have a unique ID and can keep it as a secret. Maybe it's a barcode set by its manufacturer, or a PIN code that is assigned by the owner of this home network. Thirdly, there must exist some out-of-bound way to share devices secret to the authentication server. For example, you can use the scanned barcode or just enter the PIN code to the authentication server. About the bootstrap process, I will highlight some things here. And the first step, the owners should give the ID of the new device to the authentication server. Then the authentication server initiates the bootstrap process by just probing the new device. This process is secured by the secret shared with the target device. Then the device applies, generates a key pair and applies a signed certificate from the AS. And the AS will sign this public key and reply with the signing certificate. The device then requests the trust anchor and requests a signed certificate. So this is the high-level steps. For this demo, we just use the C++ for implementation, and we use the CXS library, and we must have the NFD run separately. It's the local forwarding daemon. So the basic configuration is that we have one laptop acts as the authentication server, and 2 VMs emulate something like temperature sensors. Then we have another laptop acts as the consumer. So what to demonstrate later, I want to show 2 processes. The first process is the bootstrap process that enables devices join the trusted network. The second process is the auto-discovery process, which helps devices to find out services in the network. So I will first run the authentication server, then I will run a client device here. And set its secret as 1, 2, 3. Now, before going to the bootstrap process, we can see that without bootstrap, although the device can try to discover some services from the network, but it cannot get anything. We can see that there are some interests out, but it's time out, because at this point, no one can trust this device. Then let's start the bootstrap process. Okay, sorry, I just write some tool here, but I can't remember the command.
So while he's doing that, just to quickly break that down. So that's an interest leaving the device that is the publisher of the temperature data. In red, the name /localhop/probe-device is a convention that says to the first part of the prefix says to NFD, forward it 1 hop, right, on all of my interfaces. The probe-device is a name that his application invented, but the idea being that it's a convention that says I want to learn about other devices that are on the network. So the combination of name that NFD understands and name that the application understands is performing the function of discovery. In this interest, he also includes the pre-existing name of his device and a MAC authentication, HMAC authentication. Why it's named /Shannon, I'm not sure, because it wouldn't know that. But
yeah.
But and so the second part of this is that there's actually a signature embedded in the name, so that this interest could be authenticated. So if you remember from Beishuan's introduction to the protocol earlier this morning, there are no signatures in interest packets and there are signatures in data packets, but names are very flexible, and so if you want to have an interest that has an authenticator with it, you can add it on as a name component. And so that's what he's doing here. So in this example, even the discovery process or bootstrapping process on the network, discovery and bootstrapping can only be done by authenticated devices, and that's done by putting this HMAC authenticator into the name of these requests that go on the network. That has some implications, one of them being you can't cache or aggregate the data corresponding to that interest. You can't aggregate interests, but you get in return the ability to authenticate the interest.
Okay, so then let's start the Bootstrap process.
So you have to describe what you just did.
Okay, sorry. I just want to start the Bootstrap process by typing this command here.
So while he's working on that, I'm going to try to explain what just happened. So over here, remember this was the temperature sensor, and he initialized it with a shared secret 123, a PIN code. That's just like a QR code on that device, right? And over here, these are processes running on the authentication server, and you'll notice that in the command that he cleared, there was a command line argument 123, which was that PIN code. So the assumption is that by scanning a QR code or typing in a PIN, this out-of-band secret that's known to the temperature sensor publisher is given to the authentication server, and then the authentication server initiates this bootstrapping process. So similar to maybe if that authentication server was running on a mobile, or you had a mobile client through your home router, you scan a QR code that corresponds to this new device over here, exchanges the shared secret out of band, and then in this case uses that to initiate the bootstrapping process. And so far we're just talking about interest data exchange using a set of specific conventions. Okay, so on the left, this is the command.
Yeah, the command 92 to control the server to some, for example, to start the Bootstrap process, and I can also enable some debug mode so that we can see more detail into the process. I also wanted to enable the debug mode on the device. Then I want to start the Bootstrap process. Separate. So here, the first step is that the authentication server will send out probing interest to the broadcast this request to the network. Then this device, we can see that the device received this interest and will reply this probing interest with its name, and here we can see that this is the device's name. Reply with his name here. And then when the server receives this response, it can register some the device's name to its local forwarding daemon, so that it can receive the device's interest later. So here we also can see that after the device replied the probing interest, it will send out request to ask the authentication server to sign its public key, so that its later interest can be verified on the network. So the step 3 is that the device in step 2 the authentication server will only send the authentication server's certificate to this device, because this device needs this certificate to work as the trust anchor. So in step 3, the device will request the authentication server to just send the signed certificate to it. So here we can see that when this device gets this certificate, it will just start the discovery process. In this step, and at this point, we can see that it can discover the authentication server with one services. Actually, this service is just the certificate of this device, because the authentication server will supply the certificate to the network. So when other devices want to fetch this certificate, it can just go to the authentication server. So this is the first device. Let me ask, and the second device here.
So why don't you switch to the slides and just reiterate the exchange, and then we'll wrap up.
Yeah, this is a Bootstrap process. For the first step, the authentication server will first send out an interest to the device, and the device will reply this interest with its name, and then the authentication server will verify this reply and register the device's name to the local daemon so that it can receive the interest later. And at the same time, the device will send out a request to ask the authentication server to sign its public key. And the server verify this reply and then send out the server's key and the device's trust anchor. Then the device asks for the signed certificate, and then when it gets this certificate, I think the Bootstrap process is done here.
So I think we should stop
Okay.
there.
So for the discovery, when every device gets the certificate from the authentication server, they can trust each other with the help of the authentication server. For example, when one device wants to fetch the certificate of another device, it can directly go to the authentication server to get this certificate. Then it can verify the signature by any packet from the target device. And this discovery process is in the broadcast manner. So when one device wants to discover services, all devices in this network can respond to this interest. And once this requester is trusted by the network, they can get all available services in this network.